Assalamualaikum and hi everyone. Today me and my friend Amir Hamzah are going to discuss with you guys about electrostatic. Okay, before we go further in this topic, let's take a look on the objective of this video. Okay, so first we are going to cover on electric force, then electric field, then electric potential and electric potential energy. Okay, for the first topic is electric force. An electric force is an interaction between two electric force. This force, unlike charge, attract but do like charge repel. Positive charge will attract negative charge, so the electric force between them is attractive. The electric force is repulsive for two positive charge or two negative charge. So here I attach the diagram of electric force. Two stationary point charge Q1 and Q2 in a vacuum separated by distance r. Electric force of magnitude F acts on each charge. So two forces form an action-reaction pair. According to the third Newton's law of motion, magnitude of force acting on Q1 is going to be equal to Q2. Okay, so this is the equation of the electric force. So F is equal to K Q1 Q2 over R squared. Since K equals to 1 over 4 pi permittivity, then we can conclude that F also equal to Q1 times Q2 over 4 pi permittivity R squared. Okay, now these are the applications of electric force. The first one is the charge in bulk, then electric circuit, static friction between cloth when rubbed by a dryer, and also shock that is felt after touching doorknob. Okay, now let's move on to the next topic, which is electric field. An electrical field is a region in which electric force will act on a charge that is placed in the region. Charge or an electrical potential difference across two conductors can produce an electrical field. Hence, electrical field exists in the space surrounding the charge. Okay, so here I attach the diagram of electric field. So as you guys can see, the positive charge will go out from the particle while the negative charge will go into the particle. So that we can conclude that the charge always travel from positive to negative. And not to forget, the further the particle, the weaker the attraction. Next, when two particles with the same charge will repel, while two particles with different charge will attract each other. So electrical field lines have the following features. So they do not intersect each other. Each electrical field line has the direction. So the direction is the same as direction of the motion of the positive charge that is allowed to move freely in the field. This means the line points away from a positive charge that will produce the field. The line points toward a negative charge that produces the field. So the positive charge is attracted by the negative charge. It will move towards the negative charge, and this also means that the line flows into a negative charge. So electrical strength vector E at a point in an electric field is tangential to the field line that passes through that point. So this is the equation of this electric field, which is E equals to F over Q or F equals to QE. So E has a unit of Newton per coulomb or volt per meter. So these are the applications of electric field. So the first one is electroporation, which is invasive technique where electric fields are used to make pores in cell membranes to insert drugs, medicine or genes. It is widely used in cloning processes. Second one is tissue dynamics. So it is widely used to study tissue dynamics. And the last one is control different crystallization process like nucleation, crystal growth, and etc.
Next, we move on to the third objective of this video, which is electric potential. So electric potential, denoted by symbol B and a scalar quantity, which is a physical quantity that has magnitude but no direction. It represents the amount of electric potential energy per unit charge and usually measured in volts. So the definition of electric potential is a work done per unit charge in bringing positive test charge from infinity to that apply the basic concept formula of work, which is work equal to force times distance times angle. And there are a few applications of electric potential in our daily life. First, in household electronics. These household electronics are powered by batteries and power outlet, and that can provide electric potential to the device. For example, refrigerator and water cooler. While in medical field, there are a few medical devices that use electric potential to monitor and regulate physiological function of human. For example, defibrillators, pacemaker, and electrocardiogram (ECG). And finally, the charging devices such as laptop and phones that has cables that use electric potential to transfer energy from power sources to recharge batteries of the devices.
Now, we move to our final objective of this video, which is electric potential energy. So, electric potential energy is basically the energy that a charged particle possesses due to its position in an electric field. And this energy arises from the interaction between charged objects within the electric field. For the definition, electric potential energy is a work done in bringing a charged particle from infinity to a particular point in an electric field. It represents the potential ability of the charged particle to do work due to its position relative to other charged particles in field. And for its unit, it's typically measured in joule, where 1 joule defined as 1 coulomb of electric charge move across an electric potential difference of 1 volt. And it also can be expressed as 1 joule equals to 1 coulomb times 1 volt equals to 1 coulomb volts. So now we see the diagram that shows how electric potential energy works. As we can see, there are a Q1 which is a charge 1 and Q2 which is a charge 2, and there are a distance of separation between them. So to calculate electric potential energy, we need to apply a formula. Electric potential energy U equals to K, which is a coulomb constant, times Q1 Q2 over R. Now there is application of the electric potential energy in our daily life. First, we have lightning. Lightning is a natural phenomenon that occurs due to the build-up of electric potential energy between clouds and grounds become large, and it results in discharge of electric in form of lightning. Next, we have electroplating. Electroplating is a process to coat metal object with a thin layer of another metal, and it relies on electric potential energy to deposit metal ions onto the surface of the object that are being plated. And finally, we have hydropower. Hydropower plants harness the potential energy of water stored in dams, and the potential energy is then converted into kinetic energy as water flows downhill due to the gravity. And the kinetic energy is used to generate electricity through turbines. Now, I would like to explain to all of you guys about the differences between electric potential and electric potential energy in a few aspects. First, for the symbol, electric potential use P as the symbol, while electric potential energy use U or PE that indicates it as potential energy. Next, for the dependence factors, most of this concept depends on the charge of objects. However, the electric potential depends on electric field strength, while electric potential energy depends on the position of the charge in the electric field. Next, for units and measurement, electric potential use volts. However, the electric potential energy use joules, since it's a kind of energy. And finally, for the representation, electric potential describes the electric field's ability to do work on a unit charge, while electric potential energy represents the work done to bring a charge from infinity to a particular point in field. For Islamization, in an Islamic perspective, understanding electricity connects the belief in Allah's creation and the responsibility to care for it. Electric force and fields are seen as part of Allah's design, showcasing balance and order. Electric potential and energy represent blessings from Allah, which can be used for good, reminding us to use resources wisely. Seeking knowledge about electricity aligns with Islam's emphasis on learning and serving others. This approach promotes sustainability and ethical behavior, reflecting gratitude for Allah's gift. And finally, for the conclusion, Electric force and electric field describe how charges interact and influence each other. On the other hand, electric potential and electric potential energy quantify the energy associated with this interaction and the arrangement of charges. Together, they provide a comprehensive understanding of electricity and its applications. So I think that's all from us. I hope you guys understand what we have been delivered.